Hey Math fam, with me today is a very interesting factorial problem. It says, so for n in the expression n plus 5 factorial over n plus 1 factorial equals 3024. Now for those of you who don't know factorials, this exclamation mark is a factorial and it represents the following product of any natural number. Take for example a natural number 5. Now 5 factorial would be 5 times 4 times 3 all the way to 1. In simple terms, 120. Generally speaking, this is written as n factorial equals n times n minus 1 times n minus 2 all the way to 1 for all n greater than or equal to 0, basically natural numbers. Now, back to our question. So there's actually a way to divide n plus 5 factorial over n plus 1 factorial. To do this, we'll just play around with n plus 5 factorial. We know that n plus 5 factorial is the following product for n plus 5. That's n plus 5 times n plus 4 times n plus 3 times n plus 2 all the way to 1. Let's go to the point where it reaches n plus 1 times n minus 1 all the way to 1. We know that n plus 1 times n all the way to 1 is basically n plus 1 factorial. And just like that, we've factored out n plus 1 factorial from n plus 5 factorial. Now let's do some basic division. N plus 1 factorial will cancel out with the n plus 1 factorial. We're now left with 4 brackets. If you're the algebra guy, then you can almost instantly tell that this product is going to give us a quartic equation, which gets very messy. But we can do this in a simpler way. We have the numbers 3 and 4 and 2 and 5. These pairs both sum up to 7. Why is this useful, you may ask? If we expand any expression a plus b into a plus d, we get a squared plus ad plus ab plus bd. From the middle terms, we can factor out a to get a into d plus b. And d plus b is basically the sum of the constants. Then we apply that here. Here we have n plus 2 into n plus 5 or something like that, or n plus 3 into n plus 4. We know somewhere, somehow, we will have a into d plus b, which in this case would be n into 3 plus 4 or n into 2 plus 5. Basically 7n. The expansion always starts with an n squared, so basically the common terms from these two expanded brackets will be n squared plus 7n. But then comes the difference when I just use the n plus 2 into n plus 3 or n plus 4 into n plus 5. Then we'd have something like an n squared plus a 5n, then an n squared plus a 9n. So this was actually very clever. Let me show you how this helps. If we expand all the way through, then we'll have n squared plus 7n plus 10 into n squared plus 7n plus 12 equals 3024. Let's call n squared plus 7n some new term, say x. Then we'll have x plus 10 into x plus 12 equals 3024. The difference between these two terms is 2. We know n must be a natural number, thus must be a positive integer. And so we need to look for factors of 3024 that have a difference of 2. 4 can be a factor to give 756 times 4. We'll divide 756 by 2 but multiply 4 by 2 to keep the product the same, and also bring the difference closer to 2. This results in 378 times 8. Now, you may not see straight away, but 378 is divisible by 7, so we can divide by 7 and multiply by 7. This gives 54 times 56, and these two numbers have a difference of 2, so this was our goal. The lesser one will be the x plus 10, so x plus 10 equals 54, and x in this case will be 44. Of course, there's another case with negatives, but these are factorials, and factorials are not described for whole number negatives. So basically x is 44. Then we'll substitute what x was previously. X was n squared plus 7n, so n squared plus 7n equals 44. Then we factor out the n to get n into n plus 7 equals 44. The two numbers have a difference of 7. Basically, the factors of 44 with a difference of 7, we can have 22 and 2, then 11 and 4. And of course, 11 and 4 are the numbers we're looking for. So basically, the lesser one will be equal to n, and thus n equals 4. Now let me explain the reason why we did that kind of regrouping for the brackets. Like I said, the other constants didn't have the same sums when paired up. This may have led to something like this. And remember how last time we let n squared plus 7n equal x? Well, we can't do that for any of these equations because of their different sums. So here, we don't have any constant terms you can pull out. I mean, you could pull out the squared, but it's already one defined term. It doesn't change anything. And this forces a quartic equation that can't be dodged. Therefore, when we were doing this clever grouping, it forced us to combine the terms n squared and n to make it a quadratic and simplify it easily. Okay, baby English, we basically removed 2 degrees from the quartic equation to make it a quadratic equation. That's the simple math to it. Yo, this problem was exciting, interesting, and everything, bro. Factorial's good, but algebra on the other hand, man, it's a beast. Subscribe!